Okay, so Rahul Negi this side.
Yes, sir.
Okay, fine. Rahul Negi, so you have applied for the data scientist role in our company. Is
Yes,
that
sir.
true?
Yes, sir.
Okay, so Rahul Negi, can you give a brief introduction about yourself?
Okay, so good morning, sir. My name is Rahul Negi. I am currently pursuing BTech in computer science from GGSIP University. I am currently in my fourth year, and okay, I'm very inclined and curious about machine learning, deep learning, and all that other stuff. I like to try out various experiments, and I like to try build my own models and see what I can achieve with the help of them.
Okay, fine. So you have said that you have done deep learning also.
Yes, sir.
So do you know about GANs?
Yes, sir.
What is the full form of GAN?
So the GAN is an acronym for Generative Adversarial Network, sir.
Okay, can you explain it in a brief manner?
Okay, so basically, sir,
You
GAN
can
is
use
a
your whiteboard, okay? I have given you the permissions.
okay, sir. Okay, so I can say that, sir, that GAN is your basically generative adversarial network. Okay, so what it is, it basically has two key components: a generator and a discriminator. Okay, so what does
Mhm.
it does is that this, let's say, this is your generator. Okay, so generator and discriminator are both neural network at their very core. Okay, so you feed them your generator some information and to process on them, and after some time it start to produce its very own samples regarding that. For example, if you
You have said two key components. I can see only one.
okay, sorry, I got busy in the explanation. Generator and discriminator. Okay, so let's say, for example, you train your generator, you train your GAN on images. So what will happen after some times? Your generator will start to produce their very own
So
images.
GANs are always trained on images.
No, sir, you can train on images, numbers, text. They can be anything. They are basically neural networks.
How do GANs take text? Do you know about that?
Sir, yeah, you have to basically GANs. See, GAN is basically neural network. The
Okay.
generator and discriminator are both neural networks.
What type of neural network?
They are a mix. They are mixer. They are not a single neural network. Okay, you can say it solely depends
A
upon.
mix of what? Mix of what?
It solely depends upon what for what purpose you are building your GAN model. If your sole purpose is to just make your GAN work with numbers, then I would say then you can just keep your generator and discriminator as an ANN. Okay. If you
Correct.
want,
Okay.
if you want your GAN to work on images, then first what we have to do, you have to first make a CNN. CNN will pick out extract features from those images, converted them to a numerical value. Then you have to pass on these value to an ANN. This will work upon them, and this will provide you with some output. Okay. Now add text. For text, what we need NLP, sir. Okay, we need to perform.
All right. We need some processing on the language so that my text can convert it into some, I can say, some numbers.
On some vectors.
Or what we call is a word embeddings, right?
Yes, sir. From then on, you can use your normal ANN to produce some output as you desire. So it solely depends on for what purpose you are using your GAN.
Right. Okay. Okay, good. That's very good. So Rahul, just explain me the working of GANs from start to end.
Okay.
On images. If I want to train my GAN on images. Okay. For images.
Okay. So for most of the GANs, you need to have two things. Okay. First, you need sorry, not two things. I would like to say. Let's start. Okay. So here is your generator. Okay. Let's say this is your generator neural network. This is your discriminator neural network. Okay. So generator it basically has some it first what will generator do is it will take some random noise, it will work upon it, and it will produce some images regarding that.
From where this random noise will come?
From where this random noise will come? It can basically we provided this random noise. Random we provide it with some random noise, sir.
Okay, you will provide it. That means what we want to train the GAN is first the random sample, and second, what you have said. Any other thing you want to know? You want to have firstly?
Actually, what will happen, sir, we don't need this. What will GAN generator do is, and when I explain, I'll explain it to you and then I'll answer your question. Okay, let's say we provide
Okay,
it
okay,
with some
fine.
random noise. This generator, what will do is, it will work upon it. This is basically a neural network. It will work upon it. It will produce some output. Okay, then we will pass on this output to a discriminator. The discriminator has two functions, will receive two inputs. First, it will receive from generator, and after that it will receive a ground truth. Okay, ground truth.
Mm-hmm.
The ground truth is the real value. Okay.
Mm-hmm.
And then what will discriminator will try to distinguish between them. It will try to differentiate between them, between that, let's say between the value that
Differentiate
the
between
generator
what?
provides. Sorry, sir.
Differentiate between what?
Yes, sir. The generator, let's say discriminator will receive two values. It will receive one from the generator, the output of the generator. Second thing, we introduce it, we just input it is the ground truth. So it will differentiate between these two values, between, you can say, the fake value and the real value. Okay,
Okay,
and
okay, okay, fine.
it will differentiate it. It will try to differentiate it. If it differentiates it, it will just output. It will just say to the it will just, you can say, pass on this information to the generator. Then the generator will receive the output from the discriminator and retrain itself, so that the next time, in the next iteration, it will produce some better output. Okay, so this cycle, you can say, it goes on until our discriminator is unable to differentiate between the fake value and the real value. Okay, so
Mm-hmm.
after that what happens is, after that after that what happens, sir, is our generator gets trained so well that from random noise it will be able to produce a direct output.
So is there any backward propagation will be a helpful tool?
Yes, of course, sir. Basically what generator and discriminator are, they are neural networks. So in neural network, back propagation always helps, because it will help you to adjust your weights and biases, so that the ultimate the loss gets low. Okay, the loss function gets the loss value gets it goes down. So back propagation is always a
So
good thing.
what is the what do you want for the disk loss? Means what is the appropriate value do you want me to be the disk loss?
Sir, in my opinion, sir, discriminator loss should be high.
No, no, no. I'm just saying what is the appropriate value do you want for the discriminator loss to be happen?
Discriminator loss value.
Yeah.
Okay. Uh,
Means that means what do you want it? Suppose it should be 0.1, 0.2
I
or
think that
0.9.
it should be 0.5, because that means that the discriminator is unable to differentiate between the real and the fake value.
Yeah, that's what I'm asking. That's what I'm asking.
Okay.
Okay, that would be good. I can say now we can go and move forward for the different types of GANs you know about them.
Okay, so sir, so basically, sir, GAN is a hot topic, as you would know. Okay, so basically there are different types of GAN that there are available on the internet. Okay, so for example, there is cycle GAN, there is pro GAN, then there is ESR GAN, there is SR GAN, and there are info GAN. There are different types of GANs that actually.
I just want to know who invented this GAN.
Who invented the GAN, sir?
Yeah, who introduced the this topic of GAN to everyone?
So I don't know the actual name, but I just know that it was published in the Goodfellow research paper in 2013 or 14. I'm taking a random guess here. I don't remember the name of the person who introduced this, but this was a
The research paper was Goodfellow and the name was Ian Goodfellow.
okay, that Ian
Did you
Goodfellow.
remember?
Okay, actually,
He published the first research paper on GAN.
yes, sir. So this was the
So,
groundbreaking
do you like
revolution.
reading research papers?
Yeah, sorry, sir.
Do you like reading research papers?
Sir, basically, they are the only source of uh, if you, for example, if you want to study, if you want to know about GANs, so I think
Mm-hmm.
there are only two platforms that provide that adequate information about GAN. The first one is that research paper. The second one is step coding.
Coding.
Yes, sir. The NADOS content of step coding. It is very good. I think you should check it out.
Okay, I will. I will. For sure, I will. Um, that would be good for this. I I need to know that in GAN, why do we need a cycle consistent loss? Why do we need it?
Cycle consistent loss, or this loss was introduced with that with you can say with cycle GAN. Okay, so this loss was basically introduced with cycle GAN. So
Mhm.
cycle consistent loss, it was introduced with cycle GAN. So but
Mhm.
actually happens with cycle GAN is that let's say you have
So
one
can you
image.
explain first of all for the loss? Can you explain the cycle GAN?
Okay, I'll explain you the cycle GAN. So what basically
Yeah.
cycle GAN, I'll just erase this. Okay, so cycle GAN was cycle GAN is very popular for let's say you have a scenario
No,
where
I
you,
know. Whole GAN is popular.
yes sir, but
Whole
if you
GAN is
want,
popular right now.
but basically what but main you can say feature of GAN is that you need two images. You need some fake image and you need the ground truth. Okay. For example, what cycle GAN does it superimposes two photos. For example, if you have an let's say you have a horse pic and you want to convert it into zebra pic, then you will use cycle GAN. So it will superimpose
Mm.
that pixels of zebra upon the horse. Am I audible, sir?
Yes, you are audible. Audible. Continue.
Okay, so cycle GAN basically has it has two generator and two discriminator. Okay, so two generator and two discriminator. It so basically,
Mhm.
do you have any doubts, sir?
No, no, no. I don't have any doubt. You can continue.
Okay, sir. Okay, so basically, the cycle GAN is as I earlier said that you require cycle GAN when you want to convert images. For example, you want to convert summer images to winter or vice versa. So what happens is you have two GAN. Let's say this is this is G1
Or I
GAN.
can say, in simple terms, I can say that you want to convert some variations into another variation,
Yes, sir. Yes, sir. There some variations
some
into
particular type of variation into another variations,
yes,
right? Let's say I have a night image and I want to convert it into a day image.
yes, sir. Yes, sir. So
Is it can be performed by cycle gun?
yes, sir. It can be. It is actually performed by cycle GAN. It produces some of the best result when cycle GAN is applied.
Okay, so have you done any projects related to GANs?
Yes, sir.
What type of project? Can you mention them?
Okay, so I basically, sir, I basically you can say the best GAN I have worked on is the Pro GAN. Okay, I actually built a project around Pro GAN as well. So
Mhm.
I basically worked with a Celeba dataset. Okay, it is basically a celebrity dataset, and I trained my GAN over this Celeba dataset so that ultimately it produces images of people that do not exist.
Mhm.
So I basically worked on this GAN program. I worked upon
Can
this
you explain that GAN?
program. Okay, sir.
Yeah.
Okay, sir. So, sir, program is again an acronym for progressive GAN. Okay. So what
And
actually
I
does
think so.
is
This program is a unique, uh, I can say, is a unique GAN from others.
yes, sir. It is unique because let's say in normal GAN, that generator, sorry, this generator and the discriminator. Okay, their input size is fixed. Okay, let's say, I think, sir, my network is not that good because I'll just try it once again. Let's say this is my generator and this is my discriminator. Okay. I think there is some error, sir. I think I'll explain it to you this way. So what actually happens with cycle GAN is, sir, let's say your the input layer of a generator and a discriminator is fixed in every other GAN. Okay. We know that
your writing is not visible on whiteboard. Are you writing on the whiteboard?
no, sir, I'm not writing. I think it's my internet connection. It's not working that well, so I won't be able to explain it on the whiteboard. I'll explain it to you.
No, continue. Your writing was visible. Your writing was visible.
Okay, I'll just try once again, sir, because you are insisting. Okay, so what basically happens is, sir, that your generator and your discriminator. I think now you can see, sir, it is not visible. So I think there is a problem from my side. I'll explain it to you.
Repeat it again. Repeat it again.
Sir, okay, so this is your generator and this is your discriminator. See, I think you can see now, sir. Okay.
No, your G and D are visible.
Are they visible, sir? Okay. So what happens is this basically that input layer of this generator and input layer of this discriminator is always fixed. Okay. But what happens with ProGAN is ProGAN stands for progressive GAN. So you are progressively growing your GAN.
Your circle is outside the rectangle.
I am telling you, no, sir, they say there is an internet issue from my side. So that's why I'm not able to go ahead with the writing. If you are comfortable, I can explain it to you orally.
Okay, continue.
Okay. So what basically happens is with ProGAN is, sir, you progressively grow your GAN. You progressively grow your network. For example, what actually happened is
it a LinkedIn or something?
Sorry, sir?
You are saying it will progressively grow your network. So is it a type of LinkedIn?
No, sir. No, sir. It's not LinkedIn. But I'll suggest you, for example, what happened with ProGAN is we initially start with a small dimension of images. Let's say I start with 4x4. Then what will happen is I will increase this 4x4 to 8x8. Once my network has been mastered upon this 4x on producing 4x4 images, I will then train my network to produce on 8x8 images. After it has been trained, I will shift it to 16x16, then 32x32, and I will continue to do this until I get a high definition image, that's 1024x1024. So you can see, sir, that from here it is progressively growing.
Okay. So you are talking about images.
Okay, yes, sir.
Okay, so first of all, this is my image. So it will first of all make it this 4x4, then 8x8, then 16x16. Is this correct?
Yes, sir. And it progressively grow your images.
Okay, fine. So let's say, just wait a second. Just wait a second. Okay. So let's say I have my image like this, right?
Yeah.
So first of all, it will generate the legs, right?
No, sir.
Will it be generating legs or will it be generating the whole person in 4x4?
Whole person in 4x4, sir. This will happen.
Okay. Whole person with 4x4.
Yes, then it will increase.
So how is it growing? How is it growing? I can say then it will draw this person in 8x8.
Yes, sir.
So you are not extracting the features.
The features, sir.
Like this, now you are not cutting up the features.
No, sir. No, sir. We are basically taking this whole image, but in 4x4 first, and then we'll take in 8x8, then 16x16, and so on.
So how does this person have image? Okay, fine. I understood. This person will fit into the 4x4 image.
Yes, sir.
So you are basically resizing the dimensions.
Yes, sir.
Okay, so first of all, so what is the size of image you will give? Firstly, I can say you will give some images on discriminator as a ground truth.
Yes, sir.
I can say this is G and this is D. Okay, and I can say this is the ground truth and this is the output generated from generator. Okay, So what is the dimension of the ground truth?
So actually, ground truth has a dimension of 1024 cross 1024.
Okay.
Basically, sir, what happens is your generator.
And what is the dimension of generator?
Generator will have an generator will start on 4 cross 4.
Okay, so it will first of all trained on 4 cross 4 means it will sorry for it. It will generate a 4 cross 4 image. Okay, it will master upon 4 cross 4 image. Then how it will go for the 8 cross 8?
Actually, sir, what happens is if I will just show you that model of generator. For example, in the first layer you will have a 4 cross 4 layer. Then you will have an 8 cross 8 layer, and so on. This is your generator model. Okay, this is your generator model, and at the last you will
So
have
it will take a lot of training time, you know.
Yes,
right? It will take a lot of training time.
Yes, sir. Actually, what happens is that progressive GAN.
First of all, it will train on 4 cross 4. Then it will train on 8 cross 8. Then it will train on 16, and like this it will go on.
Oh, yes, sir. But actually, in the research paper that was published on ProGAN, that they said that they used an 8-core TPU. That 8-core TPU was used for 4 days straight to produce high quality images. So you can say that it takes a lot of time and a lot of computational power because TPU were used actually.
So you have these 8 TPUs in your computer?
No,
do
sir.
You have these?
Actually, I don't.
So how you are saying that I have made this project of celeb dataset?
I made this project, but I actually used a hack. I basically used a hack.
Okay, so you have used the hack, the
Yes.
ingenious thing, yeah?
Yes, sir. Instead of training my image from fork or force, what I did, I trained my generator from 128 cross 128. So the training time was significantly reduced. After 128 cross 28, I just jumped to 256.256, then 512 cross 512. And
okay. So you were not training on 4 cross 4 images. You were training on 128 cross 128.
Yes, sir.
First,
I did not
the
start
initial
from,
image you have made was 128 by 128.
Yes, sir. I did not start from that. You can say that just from the ground. I started from 128 plus 128.
That is very cool. You have good hack. You have good hack. Okay, so I want to know the key features of this program.
Okay. So basically, this program it basically has three features. Okay. So the very first feature was that it progressively grows your network. Okay, the progressive GAN. This was the first feature. The second feature was it basically.
Don't say about the progressively grow your network.
No,
So
sir.
I will understood that it will grow my network of persons. Don't say that.
Okay.
Give it another word.
Okay. I won't use that word. Okay. And the second key feature of this program was that it initialized equalized learning rate. Okay. So what it basically does was that my generator and my discriminator will both train on an equalized learning rate because I don't want that my generator get trained first and my discriminator does not get trained, because that will destroy the whole purpose of my GAN. Okay, if my generator got trained very fast and my discriminator is not getting trained at an equal rate, it will ultimately damage my generator. It will ultimately damage my GAN. Okay, so what it does, it initialized an equalized learning rate and equalized, and it also scaled down the weights. Okay, so what it does is the third feature was pixel normalization. Instead of pixel normalization was also a key feature of this program, sir.
Okay. Anything else?
I think that's it, sir.
Okay, well, that is very good. So we have talked more about GANs. We have talked here, but I want to know the basic thing. That is the basic thing, the loss function of GAN.
Okay, loss function of GAN. So
yes,
if I have to write the loss function of GAN, then I'll say that the loss function of GAN, then loss function, but basically is happening is we are minimizing our generator loss and we are maximizing a discriminator loss. So this basically constitute the main, you can say, the crux of loss function, that all we have to do is you have to minimize the generator loss and you have to maximize the discriminator loss. Okay. The formula you can say is something like, you can say loss function is equal to, you can say, Px log of Gx plus E of Pz log of 1 minus dgx. Sorry, this is dx, I think. So this is your loss function, sir.
EPX log of, correct me if I'm wrong, EPX log of d of x plus EPZ log of 1 minus d of g of x. What do you mean by this? Wait a second. What do you mean by this d of g of x?
Okay, so basically I have to draw a diagram for you to understand. This is a generator, sir. This is a discriminator. Okay. Generator, what will do, it will take some random sample. Okay. And it will generate some output of it. Let's say it is g of x. It is a function of generator. Okay. This output that has been produced is, let's say, g of x, gx. Okay. Now, what will happen is that, again, here discriminator has a ground truth, as I explained earlier. Okay. Discriminator will receive two functions. One is the, two values. One is the generator value and then is the discriminator value. So ultimately what generator has to do is it has to differentiate between this and between this. I have denoted ground truth with the value of z. It has to differentiate between these two values. So what?
Okay, so this d of g of x is nothing but the output of generator.
That after it has been passed on to the discriminator.
Right?
Yes, sir.
Fine. Okay. And that's why we are minimizing the generator loss. Okay, right? And we are what? Maximizing the discriminator loss. That is true?
Yes, sir.
Okay, we are minimizing the generator loss and maximizing the discriminator loss.
Yes, sir.
Is it true?
Yes, sir.
Okay, why we are maximizing the discriminator loss?
Because, sir, in GAN, the ultimate goal of the GAN is to fool the discriminator. Okay, we don't want the discriminator to distinguish between the real value and the fake value. Okay.
Okay. That is why after each and every epoch, the discriminator loss should be high.
Should be maximized so that ultimately when our generator gets correctly trained, it won't be able to distinguish between the real value and the fake value.
Okay. So after let's suppose this is G and this is D, and after the D will not be able to distinguish from the real one and the fake one.
Okay.
Yes. Then after that, what will happen?
What will happen is after that, okay. Now our model is trained. Now our GAN is trained. Now what we want some outputs. Okay. So what I'll do is I will start supplying generator with some random samples and it will produce me some outputs. Okay. So these are the outputs that we are concerned with.
Okay. So we will discard this discriminator.
We'll just discard the discriminator. We only use discriminator in the training and not anywhere else.
I can say we will use, correct me if I'm wrong, we will use discriminator to train the generator.
Yes, sir. Yes.
Correct?
Correct, sir.
Okay, so there is one competition on, do you active on Kaggle?
Yes, sir.
Okay, there is one competition going on. I can say what is the name of it? I am a painter of myself.
Yes, sir.
I am a painter of myself. So do you know about this competition? Yes,
sir. Actually, I have participated in it.
So what is your rank? Do you submit any predictions or something?
Yes, sir. My rank was actually 35.
Out of how many teams?
Out of, I think, 110 teams.
That is pretty good. And in how many entries?
I think we succeeded that in the first or the second entry.
Okay, second entry. That is pretty cool. So are you thinking of I can say, are you thinking of improving this rank?
Yes, sir. Surely, sir.
Because one of the members of our company is working on this competition. So do you want to join them?
Absolutely, sir. Absolutely.
तो सैलरी कितना लोगे डिस्कस कर ले?
Sure, sir.
कर ले?
Yes, sir.
ठीक है यार. Okay, so you are being hired in our company, and you will not have any HR interview. You are personally being directed from myself.
Okay, thank you, sir. Thank you.
ओके तो सैलरी वैलरी मैं डिस्कस नहीं करूंगा. सैलरी HR का कॉल आएगा सीधा. यू डोंट हैव एनी इंटरव्यू ऑफ HR.
ओके, थैंक यू सर. थैंक यू वेरी
या
मच.
पहले से ही पर्सनल इंटरव्यू देके आए हो?
नहीं सर, नहीं सर.
नहीं देकर आए?
नहीं
ठीक है,
सर.
कोई बात नहीं. मुझे तुम्हें पता चल गया तुम्हारी पर्सनालिटी क्या है. तो ठीक है, सीधा HR का कॉल आएगा और वो आपको सारी चीजें बता देगी. यू आर बीइंग हायर्ड फ्रॉम माय सेल्फ. ओके,
थैंक यू सर.
so that would be end for this interview. Okay, thank you for joining up. You may leave up.
Thank you very much, sir. Thank you.